Hi folks. So I want to run through a couple of examples that will help you with the Khan Academy assignment that you're going to be doing where you're solving basically trigonometric equations. I know it says sinusoidal equations right here, but sinusoidal just means basically that it's a periodic function, kind of like sine. All right, so let's take a look at these two examples. What's different about what Khan Academy is going to be asking you to do is that they're going to give a range of values that you're looking for theta. And this range may not be 0 to 2 pi. It could be something a little strange, all right? So what's going to really be key is that to begin with, you determine all the possible solutions to this basic equation, all right? So in that way, it's pretty similar to the worksheet that you've already worked on. So with a problem like this, we do know we're going to need our calculator. So, so I'm pointing out that you're actually taking the inverse sine of both sides of the equation. A lot of times we don't write this step out, but I just wanted to remind you about that. And I do believe we get back theta equal to negative 0.242, which interestingly enough is fairly close to what the ratio was equal to. That does happen with sine sometimes. For small angles, the sine ratio is actually pretty close to the actual value of the angle. All right, but let's remember we also want to find all the answers, so we're going to go ahead and do plus 2 pi k so that we get all the coterminal angles. All right, and now the big step that was on your worksheet last night was trying to figure out what that other angle was, right? Or x equal to what? And maybe if we come down here and check out a unit circle, draw a little unit circle, see if I can do that easily enough. We're looking at negative 0.24, which is an angle down here in the fourth quadrant. Not sure if I can write that very well. Looks like my pen is not working. But anyway, it's right down here. And we know we're looking for another angle that's going to have a sine value that's negative. So what other quadrant would that be in? Hopefully you're thinking straight across over here in the third quadrant, right? We're looking for an angle that's going to have the same y coordinate, right, as the angle we had. So we're looking straight over here in the third quadrant, and we want to be, if this angle right here is 0.24 units down, then we want to also be 0.24 units down over here. So we can get that by taking pi plus 0.24, okay? And then, of course, plus 2 pi k. Let's see if I can squeeze that in here. All right, so let me go to my calculator and we'll write down what that decimal is. Okay, so we have our two answers, actually our infinite number of answers. The one place here is in the fourth quadrant, and the other place over here is in the third quadrant. Hopefully it made sense how we got this angle over here from this one, right? We're using the symmetry of the circle, and we're just coming down 0.24 units from pi to get there. All right, so now that we have this, all of our answers, we can now look at which ones specifically fall within our range, right? And that's the one piece that's going to be taking it a step further than from what you were doing last night. Okay, so the first thing I think I'd like to do is kind of figure out what are these numbers up here as decimals. That'll make it a little easier to know if our angles or if our solutions for theta are falling between those two numbers. All right, and now that we've established that, all we really have to do is go through our values, using our calculator. So I know that negative 0.242 is not big enough. So the first thing I might do is add 2 pi to that, okay? And so if I add 2 pi to negative 2.42, actually, I'll just go ahead and list negative 2.42. I know that's not going to be one of my answers, okay? but just to get this string started. So now I'm going to add 2 pi to that to get its coterminal angle, and hopefully that will fall within our range that we're looking for. Right, so let me figure out some values here on my calculator. Okay, so you can see when I first added 2 pi, I'm getting 6.040, and I think that does fall within our range. When I added 2 pi again to the 6.040, I got 12.324, and that also falls in our range. But when I added 2 pi one more time, I was pretty sure I was going to be out of range because I was pretty close to the end right here. Okay, so we're going to just scratch out, cross out that number, and cross out that number, and we found 2 values that fall in the range. And all we have to do is do the same thing over here. I'll use green, I guess. Oops. Do the same thing over here for the 3.3. I see I'm using x over here. I meant to use theta. It should all be theta there. So now we're going to also have that theta equals, let's see, 3.383. That doesn't fall in my range, but once again, let me start adding 2 pi's and see how many do. Okay, and finishing up over here, we can see we get 9.667. That's after adding 2 pi to 3.383, and that does fall in our range. But when we add 2 pi again, we're falling out. So we can cross out the 3.83 and also the 15.950, and I think we found all the solutions that fall in our range. Looks like there are 3 of those. Okay? So I just want to do one more little example. This one, the next one will be quicker, where we're using tangent, just to remind you that tangent is actually easier than doing this with sine or cosine. So with this problem, I'm just changing the sign to tangent now. We're still going to have it equal negative 0.24. Of course, now I need to use inverse tangent, and the inverse tangent of negative 0.24 on the calculator is negative 0.235. Okay, but we know that there are other angles. Of course, we could add plus 2 pi k, which I'll go ahead and write in here. All right, but when it comes to tangent, the interesting part when we go look at the unit circle is, let's see, so this angle once again is kind of down here in the 4th quadrant. Negative 0.23, we'll say. That's a 2. Where is the other angle that's going to have the same tangent value? So we're getting a negative value for a tangent. What other quadrant is going to have negative values for tangent? And we're kind of looking for the angle that's going to have kind of the same length of the y to go over the same length, this length of the x. And unfortunately, I didn't draw a great circle, but where this happens is actually directly across from the angle that the calculator gave us, because the other quadrant that's got negative tangent values is the 2nd quadrant, right, where the y is positive and the x is negative, as opposed to the 4th where the y is negative and the x is positive. So it turns out that the other angle is right over here, where the y value is the same basically, except that it is a positive number instead of a negative number, and the x value is the same, except that it's a negative number instead of a positive number. So, and the cool thing about tangent is this is going to happen every time. So rather than adding plus 2 pi k, we actually, all we need to do is add pi k. So hopefully you picked that up from the video yesterday, but I just thought it would be good to remind you of that. So now, if we're trying to find all the values that are between 3 pi over 2 and 4 pi, all we have to do is start with this one value, the negative 0.235, and simply add pi every time. So let's see what some of those values are that we get. All right, so got some of these values here, and when we added pi the first time, I don't think we got in the range that we need, but adding it the second time, puts us in range with 6.047, and then adding another pi is still in range. Even one more time, 12.330 is in range. I believe 4 pi was about 12.56, but adding it again puts us out of range. All right, so we can get rid of that one and that one and that one, but we're left with 3 answers, 3 solutions that are in range here. Okay, so good luck with the assignment on Khan Academy.